So now we know that there are other types of isomers besides constitutional isomers. Stereoisomers can be broken down into two subcategories. The first that we've been talking about are enantiomers. These are stereoisomers that are mirror images of each other. We generally think of enantiomers as non-superimposable mirror images. Then there are diastereomers. These are stereoisomers that are not mirror images of each other. An example of diastereomers would be cis and trans 2-butene. Okay, we can see that while they have the same connectivity, they do not have the same orientation in space, but they're also not mirror images of each other. These two would be defined as diastereomers. Now, diastereomers generally have very different physical properties, unlike enantiomers. Let's consider for a second cyclohexane that has 3 different groups attached to it, 3 different substituents. There are 3 different stereocenters or chiral centers here, each of which is going to be either in the R or the S configuration. Since there are 3 stereocenters and 2 options for each stereocenter, we get a total of 2 to the third or 8 possible combinations that we could have. Now let's consider the relationship between them. Enantiomers will have opposite configurations at every chiral center. We can see that the pair of molecules in green that are paired together are all enantiomers of each other, since each chiral center is opposite in the molecule of that pair. But what is the situation where a molecule has the opposite configuration at one chiral center, but let's say the same at the other 2, such as these 2 molecules? These molecules would be considered diastereomers of each other. Okay, they're not enantiomers. They don't have the opposite configuration at every chiral center, but they do have the opposite configuration at one center. You can think of this as a family where you have like 4 pairs of twins for a total of 8 kids. Each kid has 7 siblings, where one of them is their twin or enantiomer, and the other 6 are diastereomers. The number of possible stereoisomers for a compound depends on the number of chiral centers in that compound. So the maximum number of stereoisomers for a compound is going to be 2 to the n, where n is the number of chiral centers in the molecule. So go ahead and look at this molecule and see if you can figure out what the total number of stereoisomers would be for this molecule based on the number of chiral centers.